Okay, I'm going to go through my answers to part F of the maths puzzles. This is a proof by induction, so we need to prove three cases: the base case, the kth case, and the k plus 1's case. So let's do the base case first, n equals 1. So sine of 1 is equal to, now sub in 1 for n, 1 plus 1 over 2 degrees times sine of 1 over 2 degrees all over sine of 1 over 2 degrees. Now let's see if this is correct. Okay, these guys are going to cancel, and so 1 plus 1 is 2, 2 over 2 is 1, so indeed this is true. Okay, good. So now let's prove n equals kth case. Well, not really prove, but we want to assume this is true for the kth case, right? So this means sine of 1 plus sine of 2 plus all the way up to sine of k degrees. We want this to equal sine of k plus 1 over 2 degrees times sine of k on 2 degrees all over sine of a half degrees. Okay, so we're going to assume this statement is true, and now we want to prove the k plus 1 case using this assumption. Okay, so what is the k plus 1 case? I'm going to just copy this part here. So we want this, right? And adding on the additional term, this will be k plus 1 degrees, right? And we want to prove is equal to sine of, and then we replace the n with k plus 2. And then we'll also need to replace this n with k plus 1. And we still have sine of a half degrees. Alrighty, so we want to prove this statement to be true. So let's go from the left hand side. So we know this thing here. This thing is equal to, we can replace the sine of 1 degree, sine of 2 degree, up to sine of k degree. Let's replace that with the thing we assume to be true. Okay, so this fraction here, we're going to replace the first k terms with that fraction, and then add on the last term. So this should still be true under our assumption. Okay, now we can see in the first fraction we've got k plus 1 over 2. So this might encourage us to think about, oh, maybe we can use the double angle formula for sine in the second sine. So let's think about that. We have equals, this fraction is still there. But now what I'm going to do, I'm going to break this up in using the double angle formula for sine. So 2, and we'll have sine of the angle divided by 2. We'll have cosine of the angle divided by 2. All right, and now, because we've done that, now we've got a common term, right? We've got a common term of this sine of k plus 1 over 2. Alrighty, so let's do that. We take out the sine of k plus 1 over 2 degrees. And actually, what I'll also do is, let's also multiply this second fraction by sine of a half degrees divided by sine of a half degree. So we're just multiplying it by 1, but we're going to factor out this sine of a half degrees as well, because that's quite nasty. So let's leave that out. Right, so the first one will be sine of k over 2 degrees, and the second one, what have we done? We've done 2. We need the 2. We've factored out this first term, but we've multiplied it by sine of a half degrees as well. And now we have cosine of k plus 1 over 2 degrees. Okay. Now, we're going to use the identity we proved in part D, right? So from part D, let's recall, what did we prove? We proved that 2 sine of A cos of B is equal to sine of the sum plus sine of the difference. Okay, so now we're going to use this fact to fix up this second part inside the square brackets. Okay, so I'm just going to copy this. Saves me from writing it all up again. So we have this, but now this second term here, let's fix that up a bit. So we have 2 sine of an angle cos of an angle. So what are we going to do? We're going to replace this with sine of the sum of the two. So that's going to be a half plus k plus 1 over 2, right? And then we're also going to add sine of the first one minus the second one. Okay, so it's going to be a half minus k plus 1 over 2. And notice these are all supposed to have degrees on them, so I'll just put them outside now. All right, cool. So what do we have here? We can simplify this a little bit, can't we? So sine of k plus 1 over 2 degrees, sine of a half degrees, that remains the same. And this part here also remains the same, k over 2 degrees. Now here we've got sine of a half, and also another half, so that becomes 1. So actually, let's just leave this as k plus 2 over 2, because we want to have a k plus 2 over 2 within our finished product. That's the thing we want to try to prove, right? So let's leave that there, degrees. And then what happens here, the half and the half are going to cancel, right? So we're going to left with sine of negative k over 2 degrees. But then we have a look, and this guy are going to cancel each other out, because sine of a negative angle is negative sine of that same angle, and it's going to cancel with the first term. And so we're left with sine of k plus 1 over 2 degrees multiplied by sine of k plus 2 over 2 degrees all over sine of a half degrees. And I believe that is the right hand side. And so we're done. So this is equal to the right hand side. And now we can say by the principle of mathematical induction, our statement is true for all n greater than or equal to 1, because our base case was 1. Okay, and that's my answer to part F.